What is the Big Bang? Actually, I get asked that a lot by a lot of different people because it's something everyone's curious about. But it has, its simplest thing is when the universe first began to form, when we can kind of mark that this is when time started. And there's actually an interesting part of it. There's a lot of the explanation for the Big Bang is, okay, we have this energy. How did this energy, which was all there is in the first, few seconds of the universe, how does that become everything we see? Galaxies and stars and planets. Okay? And actually what we can do is we have a decent understanding of how that process happened. And that we can actually take the initial energy and then show how it became matter. And we even have, there's about 5 experiments that prove that our understanding of the Big Bang is right. And there's a whole course in cosmology on that we teach you and things. And it's amazing stuff. Everyone likes it. But the thing that's intriguing, that gets people wondering, is that we don't know how that energy got there at the beginning. I mean, before the beginning, I guess would be the right term. And so I basically just tell students, this is that the answer to that question is outside of physics, outside of science. If you give me the energy, I can apply the laws of physics and tell you how the universe was made. Now, there's questions. Imagine galaxies being formed in billions of years, and then suns and planets in millions of years. And then life basically is, again, talking about, we think that the first life on Earth probably formed maybe in the first, probably the most earliest would have been first 500 million years. Okay, so it's, whenever I think of things inside a galaxy, I think of millions of years. When I think of the whole universe, I think of billions of years.
So, from the Earth's conception, it was only 500 million years later that life began.
Yes.
So life is almost as old as the Earth.
It is almost as old, and it's kind of interesting too. Is if you look at what we know from geology and archaeology about the Earth, is that the really interesting thing is, is that life formed as soon as it had a chance on the Earth. And in terms of thinking about life on other planets, that's, to me, is a really good support for the idea that could be life. Is that literally, in many different ways, we know when that first life formed, several different methods to determine it, and when the conditions were right, it didn't take long. Okay, and so now, which is promising. Okay, now of course by life, that very first single-celled organism. Okay, which is, we know had to be the first thing formed because it's the simplest, and you could imagine a scenario where you could make that. I'm not talking leaping into humans or even cats. That's too far. One thing about our sun that I have learned in astronomy is that there's nothing special about it. It's actually, there are stars that are bigger, there's stars that are smaller, there are stars that are more massive, there are stars less massive, there are stars that shine brighter, stars that don't. It's literally a middle-of-the-road star. Now, I find comfort in that, meaning that if our sun was weird in some way, then we could say, well, life on planet Earth would also be weird. It only can happen around these extreme stars, shall we say. And so the fact that it happened around an average star and that's also true of the Earth as being an average planet, so to speak. But the the sun dominates a lot in history, and it should. But actually, scientifically, to me, the interesting story with the sun is everyone has known about it and even studied it for quite a while. But the big question was, how could it produce so much energy? This was bothering people up into the 20th century, is that they said, okay, well, how can we produce energy here on Earth? Well, we can have chemical reactions. Could chemical reactions be happening in the sun? Well, they don't put out nearly enough energy, and the sun isn't made up of things that would necessarily combine chemically. And could it be gravitational energy? Could the sun be contracting and kind of falling in on itself, and that falling gives it more energy, and that turned out also not to be able to produce enough power. And so it was, you're right, it's this symbol from history that gives life, that's worshipped as a god sometimes, but scientists really had no idea how was it making the power until a breakthrough, which was Einstein, who realized that mass could be converted into energy. And that's his famous equation, E equal mc squared, where c is the speed of light. But the thing is, that how do you do that? I mean, it's easy. Well, it's not easy to write that equation. You got to be a genius to write that equation. But the minute it was heard, astronomers thought, is there something? They realized you can just put in a little calculation. You can say, okay, if I had this much mass, how much energy would it produce? And they realized a small mass could produce a lot of energy. So this could be, immediately people said this could be what happens in the sun. And it did turn out to be right. Okay, but it turns out how you do that, how you get mass converted to energy, is through nuclear reactions. And those don't happen every day. And they need hard conditions. And so it actually still kind of surprises me that it took to realize this fundamental source of life-giving energy, to realize what actually was the physics behind it, was sort of needed a genius to figure it out and then actually to implement it. And to our credit or not, I'll leave that up for folks to decide, but we have actually made what we call hydrogen bombs, which do actually use the same nuclear reactions that occur in the core of the sun. And the core of the sun, that energy comes out as life-giving life, and the new hydrogen bomb actually is explosive device bomb, but it was actually has never been used in anger. The bombs that were dropped in Hiroshima and Nagasaki were actually based on a different type of nuclear reaction that doesn't occur in the sun. So, but it's kind of when I think about that, I think, well, it's quite an achievement for us to be able to actually make a device that literally does the same nuclear reactions, but the power in it is scary, and it could really be misused. So
almost simple in a way.
Yeah, it is almost, and
Scary.
It's scary, but I actually think we're stepping back from the brink of a nuclear world war. But the other type of nuclear reaction in the sun, it's called nuclear fusion, but there's nuclear fission, which is where a heavy nucleus splits into smaller nucleus, and a little bit of mass disappears, and that comes out as a lot of energy. And that is what the atomic bombs were made up of, that were tested with and dropped. And that is actually what it would not be hard to make for terrorists. So that still scares me. But I mean, there's a lot of things you hear about suitcase nuclear bombs and things like that, and you wonder about all this stuff. Is any of this scientifically true? And it is fairly accurate that if you get plutonium, which should be hard to do because we try to protect how much, but if you get plutonium, actually, literally on the internet, you can pretty much read how to make a bomb from that. So that threat is still out there, and I still worry about it. I would actually, my sights are even lower, is that if we even discovered the proof that life, even microbial, single-celled organisms, were found on another planet, it would actually change my entire, not change, but validate my, well, I don't know about this, but I've always wished that to be true. But science, you can't wish, you have to see. And so we're getting closer and closer to be able to answer that question about some of these planets around other stars. And I actually think in our lifetime that we will get it could well be that we can prove by looking at the atmosphere of a planet around another star that there's things in that atmosphere that could only be there if life had put them there. And that would be proof to me. And that would be exciting right there, because that just means that everything I've loved since a kid, which is astronomy, science, and even science fiction, it's all possible to some extent. But and there's lots of arguments, like I said, life formed as fast as a kid. There's lots of arguments that say this will happen, but I can't believe it till it happens. Let's go back to nuclear reactions. I mean, people are scared of putting up a nuclear electricity generator nearby, but actually they shown that they're pretty good about keeping the radiation down to the same level you would get by walking across walks. And people don't even know that, for example, that there is a background radiation just from rocks that are basically sending out radioisotopes. So I mean that's the natural radiation. And I believe the climate, the global climate change, and those are things I think people need to know so they make informed decisions. Okay, and the fault is in all of our houses, so to speak. I mean, the teachers don't teach it enough, and most people don't care enough. I mean, to even if you make it as easy as possible for them to get that idea, it's sort of too much effort. Okay, but it is something. I mean, I actually when I talk to people who are experts in global climate change, like 10 years ago, I talked to those people, and they say, well, yeah, some things could happen, and now it's a question of when, not if. And so I trust their expertise and stuff. So yeah, there's a lot I'd like to know. There's a lot of misconceptions I'd like to be corrected, and I hope when people take our astronomy classes, they get some of them. But on the other hand, I've lived long enough and had to do this myself, is that the way decisions are made, political decisions are made, is very often has little to do with facts. I mean, that's too harsh to say maybe, but I mean, it has to do with persuasion. When I look at everything in nature and everything, especially in terms of looking at how the universe works, is everything is reused. Okay, even when a star dies, its dying can trigger the formation of a new star. Okay, so there's the universe wastes nothing, whether it be matter or energy. And you can even see that to some extent in the natural world, on planets and things. So that makes me really think, although I can't really go beyond this, that there is something in all of us, and it would also not be wasted. It would be reused somehow.